equations in slope-intercept form. So in Chapter 4, we are going to be looking at equations that of linear functions and how to graph them. So in 4.1, we're going to look at learn another way to graph an equation. And the way to graph it is to use something called the slope-intercept form of the equation. And that's what we're going to learn about today. So we're going to write and graph these linear equations in slope-intercept form. And of course, we're going to do some real-world problems in slope-intercept form. Our two vocabulary words, slope-intercept form and constant function. Oops, back one, we skipped one. Okay, we have learned how to write linear equations and functions in many forms, right? We've learned standard form, ax plus by equals c, and we've learned a type of linear function called direct variation form, and that is y equals kx. Slope-intercept form is what we're going to learn today, and that is y equals mx plus b. Now we still have our x and our y. They're unchanged. They're consistent in all of these, aren't they? Right? They're always there. Here we have them here. In this case, m is the slope, as we've come to know m to be, and the b is what we call the y-intercept, and it's going in the equation. Whatever that number is where it is going to cross the y-axis, y-intercept. Okay, and these are called the parameters of the equations. M is the slope, b is the y-intercept. We'll look at an example here, and this will make a little more sense, I think. So, again, m's the slope, b's the y-intercept, and this is our equation form that we're going to use for slope-intercept form. Y equals mx plus b. Well, in this case, here's an example. Y equals 2x plus 6. 2 is the slope, 6 is the y-intercept. Let's see what that means. So if the slope is 2, right, that's the same as 2 over 1. And it's a positive slope because there's no negative sign in front of it. And 6 is the y-intercept. That means it intersects the y-axis at 0, 6. And if you look, in fact, here it is, 0, 6, and the slope is up 2 over 1. Up 2 over 1. Up 2 over 1. All right. Let's try. So the key to this is to knowing what the slope is and knowing what the y-intercept is. And we'll do some practice problems with this. All right, here we have one. Write an equation in slope-intercept form with a slope. We know that m, oops, how come you don't like me? Now let's do it. We know that m, the slope, is 3 over 4. For this line, write an equation in slope-intercept form for the line with a slope of 3 over 4 and a y-intercept of -2. So we know b, which is the y-intercept, is -2. All right, so first we need to write that equation. It says to write the equation and then to graph. So it's two parts to this. So part number 1, y equals mx plus b. And now we're substituting what we know for m, which is 3/4. That's a positive slope, plus b. Well, b is a -2, so that's going to be plus a -2 or just plain -2. We know, all right, so we've written our equation. Now, the second step, it says to graph the equation. Well, to graph this equation, the first thing we're going to do is graph the y-intercept, or b, or what we call b. And b is -2, so that means the y-intercept is at 0, -2. So we'll go over to our graph on the x and the y, and we're going to go on the y-axis, and it's at -2, so we're going to go down 2, and there is 0. Whoops, I'm going to write that on the other side. Erased everything. 0, -2. All right. And now we're going to, the second step in graphing it is we're going to graph the slope. And the slope is 3 over 4, right? So we'll start, sorry, this isn't quite right, is it? We're going to start at -2, which is where 0, -2, right? And we're going to go up 3, 1, 2, 3, and over 1, 2, 3, whoops, wrong way. It's a positive slope, so we're going up and to the right, okay? And I always remember to do that. So here we are at -2. We're going to go up 1, 2, 3, and over 1, 2, 3, 4. We're going to go up 1, 2, 3, and over 1, 2, 3, 4. And there is the line whose name is y equals 3/4 x minus 2. Okay, the y-intercept is -2, and the slope of the line is up 3 and over 4. Positive slope, so it's going to the right. All right. The next, let's see if we have another example. Well, a couple guided practices for you. So here you have 2 guided practices. Good luck with those. And we'll continue in a second. Sometimes you're given equations and they're not written in slope-intercept form, that should read. And you have to rewrite them then. So then you have to rewrite. So here we're given a graph with the equation 3x plus 2y equals 6. Well, that's not in slope-intercept form, but we need to write it into slope-intercept form. So I'm going to subtract 3x from both sides because I want to get the y alone, right? Y equals mx plus b. That's what we're going for. So these cancel out, and I get 2y equals -3x plus 6. But the y has to be by itself, right? No coefficient. So I'm going to have to divide by 2, divide by 2, divide everything by 2, right? So those cancel out, and I get y equals -3 over 2x plus what's 6 divided by 2? 3. So now my equation is in slope-intercept form. Now we're ready to graph. We need to identify what's our slope? -3 over 2. What's b? The intercept is 3, or 0, 3. Okay, so the first thing I want to do is go to the y-intercept and graph it. And that is 3, so we're going to go, I'm going to make this a little bit bigger for us to work with, if I can. There we go. Okay, a little bit bigger. So we're going to go up 1, 2, 3, 0, 3, and there's the y-intercept. Now our slope is a -3 over 2. So now we're going to graph the slope. And it's a negative, so I'm going to be headed this way with my line. So I'm going to erase that number because it's in our way. Okay, so I'm going to, from here, from the point 0, 3, I'm going to go up 3 and over 2. So that's up 1, 2, 3, and over 2, 1, 2. And there's a point on the line. And I'll go up 1, 2, 3 again and over 2. And there's my other point. And then I draw a line through those 3 and write the equation on the line. Y equals, you can either write the original or the one in slope-intercept form. Either one is fine. So you get y equals -3 over 2x plus 3. Okay. Except for the graph of y equals 0, which lies on the x-axis, horizontal lines have a slope of 0. They are graphs of constant functions, which can be written in slope-intercept form as y equals 0 plus x plus y equals 0x plus b, or just y equals b, where b is any number. Constant functions do not cross the x-axis. So that's what you want to remember. Constant functions do not cross the x-axis. They are horizontal lines with a slope of 0. Okay. Vertical lines have no slope. So equations with vertical lines cannot be written in slope-intercept form. Does that make sense? Okay, vertical lines have no slope, right? It's undefined. So these equations cannot be written in slope-intercept form. You won't see them in slope-intercept form. Okay, let's graph y equals -3. Well, why don't I have a, well, I'm sorry I don't have a graph up here for us, but I'll make one. Okay, here's our y-axis. Here's our x-axis. Okay, y equals -3. What is b here? There is no b, is there? Y is -3. So that means here we go actually b -3 is b. We have no x value. Right? We have y equals 0x minus 3. That's really what this means. So all we have is b. So we go here and we go down 1, 2, 3 to 0, -3. And this also tells us that y is always -3. So this is going to be our line, y equals -3. And those are that easy to graph. Okay? I'm going to have a couple practice problems for you here on the next page. Go ahead and try those. Make sure you get your y alone on 3b. So you're going to have to do something to that too. And good luck with those. Okay. So here's a standardized test type question. I thought we'd just practice one of these. Which of the following is an equation for this slope? All right. So is it y equals -3x plus 1? Is it y equals -3x plus 3? Is it y equals -1/3 x plus 1? Or is it y equals -1/3 x plus 3? Is it A, B, C, or D? Question mark. Well, let's go over to our graph and look and see where are we crossing the y-axis. We're crossing the y-axis at 1. So B is 1, isn't it? Because this point is 0, 1. All right, so that immediately eliminates D and B. Now, the other thing we need to look at is this it's a negative slope, we know that. So both of these are negative. Now, what is the slope itself? Well, we go up 1 and over 3, up 1 and over 3. So it's rise over run, right, guys? So it's up 1 and over 3. Which answer is correct? C. Very good. Try one of these for yourselves. Okay, so here we are with our real live world problem. This data can be modeled by a linear equation. And that means you can graph it. When they say modeled by, they're meaning you can graph it. If there is a constant rate of change. Okay, we're back to rate of change. The rate of change represents the slope, right? Just like in the direct variation, that was the slope. And the y-intercept, so the rate of change is going to be the slope, and the y-intercept is a point where the value of the independent variable is 0, right? Do you remember in our rate of change and our direct variation problems? Right here is where it crossed the y-axis, wasn't it? Okay, so let's watch for that. All right, here we have use the information at the left about high school sports. Write a linear equation to find the number of girls in high school sports after 1997. Well, in 1997, about 2.6 million girls competed. 2.6 million girls competed in 97 in high school sports. The number of girls competing in high school sports has increased by an average of 0.6 million per year since 97. Okay. So we are going to do number of girls competing equals, right, G equals the rate of change. What's the rate of change? They said the increase by an average of 0.06 times the number of years. How many years is this? Any number of years, right? It depends on where you're going from. And where did we start? In this case, B is at 2.6 million because we're not starting at year 0 when there were no girls playing sports. We're starting when there were 2.6 million girls playing sports, and we're looking at it from that point on. Okay, so we graph the equation. The data begins at 0.26, that's what we just talked about, and the rate of the change on the slope is 0.06. Obviously, these are going to have to be estimates on these graphs. This isn't an exact number. Can you estimate, part C says, can you estimate the number of girls competing in 2017? Well, you can estimate, let's say the year 2017 is 20 years after 97, right? So it's been 20 years. So you have your original equation, G, back up to here, equals 0.6 times the number of years plus 2.6. So we have the total number of girls will be the rate of change times the number of years plus where we started from. So we started at 2.6, right? We're going to multiply that by 0.06 times 20 years plus the 2.6 million we started at. And we can estimate that there are now, in 2017, at that rate, there would be 3.8 million girls competing in high school sports. Here's one for you guys to try. Good luck with that. And that is it. We will see you in class.